So you've seen all those mind-blowing AI demos, but what does it actually take to go from a cool proof of concept to a professional, rock-solid application? Well, it's definitely not about hype. It's all about engineering discipline. And today, we're going to break down the essential toolkit that every single AI engineer needs. Let's get right into it.
This should look pretty familiar, right? Just a simple API call to a large language model. It's basically the hello world of generative AI. And look, while this code absolutely works, it is just the tip of a very, very large iceberg when you're talking about building something you can trust with real users and, real data.
So is this one little API call all it takes to build a real AI product? The reality is way more complex. The journey from this simple script to a robust, safe, and predictable system is really what separates a hobby project from professional engineering. And today, we're laying out the blueprint for making that leap.
Okay, our first major challenge is what I call the control problem. We've got these incredibly powerful, creative, and, let's be honest, sometimes chaotic language models. So the real engineering task becomes, how do you make them follow your specific rules and produce output in the exact format you need every single time?
The key to getting that control is something called an instruction hierarchy. Think of it like this. At the very top, with the highest priority, you have the system prompt. This is the AI's unbreakable constitution. Below that, you give it few-shot examples, which are basically demonstrations of the exact behavior you want. And finally, at the bottom, is the user message. Now here's the golden rule. The lower layers can never, ever override the ones above them.
Let's look at a real-world example for, say, a text classifier. The system prompt doesn't ask nicely, please respond with JSON. No. It commands, respond only with a JSON object, and it even provides the exact schema. See, this isn't a suggestion, it's a hard constraint that forces the AI's output into a predictable, parsable structure that your code can actually work with.
And this leads to some really critical engineering best practices. Vague requests like, be helpful, are pretty much useless in a production environment. You have to be ruthlessly specific. And a huge anti-pattern, a major no-no, is putting raw user input directly into your system prompt. You have to always keep the user's input in the user's turn, because otherwise, you're just inviting them to hijack your AI's core instructions.
So we've managed to control the AI's output format. That's great. But is the content of that output actually any good? This brings us right to our second pillar, the quality problem. How do you prove that your AI is working correctly? And maybe more importantly, how do you measure if your changes are actually making things better? Any serious production system needs a dual evaluation strategy. On one side, you've got your fast and cheap rule-based metrics, things like keyword matching or ROUGE scores. They're great for a quick thumbs up or thumbs down in your CI/CD pipeline. But for a deeper, more nuanced understanding, you need what's called an LLM-as-Judge, which, believe it or not, uses another AI to do the grading.
So how in the world does an LLM-as-Judge work? Well, we basically give another powerful model a very specific job. The system prompt here instructs it to act as an impartial evaluation judge, and its only job is to score the AI's output on criteria like faithfulness, did it actually stick to the source material, and relevance. This whole technique of using AI to grade AI is what allows us to measure these complex qualities that simple rules just can't capture.
And the results? They're totally tangible. By implementing these kinds of evaluation techniques, one project was able to increase its faithfulness score from a pretty shaky 61% all the way up to a highly reliable 89%. This isn't just a gut feeling that the model is better, it is a hard metric that proves the system is more trustworthy.
Okay, so our AI is controlled, and we've proven its quality. But what happens when people actively try to break it? This leads us to our final and maybe most important pillar, the safety problem. How do you protect your application, your data, and your users from malicious input?
The biggest threat you'll face in this space is called prompt injection. This is basically an attack where a clever user crafts their input in just the right way to make the AI totally disregard your system prompt and follow their new, harmful instructions instead. It's like hijacking the AI's brain.
And a prompt injection attack can look deceptively simple. A phrase like "ignore all previous instructions" is a massive red flag. A truly robust safety system has to be designed to detect and block these patterns before they ever even reach the model.
So a robust defense isn't just one single check. It's a whole pipeline. Every single piece of input has to go through a sequence of filters. First, we check its length.
Then we scan for those injection attempts, we filter out profanity, redact personal information, and finally check for toxic content. It's a multi-layered shield.
Let's just zoom in on one of those steps. PII reduction. PII stands for Personally Identifiable Information. Using a tool like Presidio, the safety pipeline can automatically find and scrub out sensitive data like names and email addresses. Honestly, this is a totally non-negotiable step for protecting user privacy.
All right, let's bring it all together. Control, quality, and safety. These aren't just isolated topics. They are a single, unified blueprint. This is the foundation for moving from writing simple scripts to doing professional, production-ready AI engineering.
And here's why this really matters for you. This blueprint isn't just about writing better code. It's about building a better career. When an interviewer asks you about prompt engineering, you can talk about implementing a strict instruction hierarchy. When they ask about safety, you can describe your multi-stage filtering pipeline. This is how you demonstrate senior-level judgment, not just basic coding skills.
So we've covered the blueprint for building robust AI today. But looking forward, as these models get exponentially more powerful, I want to leave you with this question. Which of these three pillars, control, quality, or safety, do you think will become the most critical, the most urgent challenge for engineers to solve first? Definitely something to think about. Thanks for watching.